Değerli akademisyenlerimiz, kıymetli öğrenciler, değerli misafirlerimiz ve ODTÜ ailesi. İçten bir selam ile saatler 5:40'yi gösterirken 7. kez tekrar hep beraberiz. Sizlerle her ay farklı konularda alanında uzman isimlerle bu paylaşımları gerçekleştiriyor olmaktan heyecan duyduğumuz Learn and Connect 540 Lecture serisine hepiniz hoş geldiniz. Bugün belki de ayaklarımız burada ama zihnimiz başka bir dünyaya odaklı. Yine gözümüz yükseklerde diyoruz ve yüzümüzü bu defa Ay'a çeviriyoruz. Panelimizin bu ayki konusunu çerçevelesek de zaten sınırları aşıyor biliyorsunuz. Her zaman olduğu gibi bu akşam da panelimizde sadece mühendislikten değil, keşif dünyasından, uluslararası işbirliğine ve Türkiye'nin bu anlamdaki bilimsel yetkinliğini uzaya taşıyan bir vizyonu sizlere aktarıyor olacağız. Ve tüm bu sürecin merkezinde ODTÜ'nün liderliğinde Türkiye'yi Ay'a taşıyan bir proje var. Her biri 5 kilogram ağırlığında, niteliksel olarak ise taşıdığı bilimsel potansiyel açısından son derece ağır gelen 2 mikro keşif robotu, CHERI mikro keşif robotları. ODTÜ'nün farklı mühendislik fakültelerinin işbirliğiyle Romer çatısı altında Zhejiang Üniversitesi, Star Vision ve Çin Ulusal Ajansı ile birlikte geliştiriliyor. Bu küçük zeki robotların projesiyle Türkiye, Ay'a rover gönderen 6. ülke. Aynı anda 2 rover gönderen ilk ülke. Ve 2028 yılında Ay'ın Güney Kutbu'na rover indirecek İlk ülke olmasıyla tarihe iz bırakacağı bu güçlü adıma güçlü olduğu, mühendislik potansiyeliyle hazırlanıyor olduğunun haberini vermekten gurur duyuyoruz. CHERI, genç araştırmacılara ilham olan yanıyla da uluslararası arenada örnek bir işbirliğinin yansıması olacak bir hedef. Şimdi sizi bu vizyonun bir yansıması olan CHERI projesinin teaser videosuyla baş başa bırakıyoruz.
In a world racing toward the moon, where AI guides exploration and micro rovers redefine what's possible, a new frontier begins at METU. On May 15th at 5:40 p.m., Learn and Connect invites you to Conquering the Moon with Intelligent Micro Rovers, the CHERI project, featuring Associate Professor Dr. Halil Ersin Söken from the Department of Aerospace Engineering. Join the team behind Turkey's first lunar rovers. Discover how METU is shaping the future of space robotics.
Evet, video için teşekkür ederiz. Bu panelde bize CHERI'nin yolculuğunda neler olduğunu, perde arkasından akademik birikimiyle aktaracak olan kıymetli bir konuğumuz var ama tabii konuk sayılmaz aslında. Kendisi ev sahibi de diyebiliriz. ODTÜ Havacılık ve Uzay Mühendisliği Bölümü öğretim üyesi Doçent Doktor Sayın Halil Ersin Söken bizimle olacak. Kendisine sözü vermeden önce Learn kısmı ardından fuaye alanımızda bir araya gelip fikir alışverişinde bulunacağımız, bağlantılar kuracağımız ve belki yeni işbirliklerinin temellerini atacağımız bir kokteylimizi gerçekleştirmek üzere panelimizin tamamlayıcı bölümü olan Connect'e geçeceğimizi hatırlatmak isterim. Connect'te görüşmek üzere diyorum ve sözü Doçent Doktor Sayın Halil Ersin Söken'e bırakıyorum. Buyursunlar hocam.
Hello, good evening. So I would like to start my presentation by asking you to imagine like you are standing on moon, actually, and specifically on moon's south pole. The sun is kind of lightening you. It is not setting at all. I mean, it is never setting completely. You have permanent shadows all around you, and under your foot, you have shadows, but on top of that, you have possible, frozen water which means, I mean, you have ice possibly. So the thing is, like Chang'e 8 mission by China will be exploring this region by 2029. And as METU, we will be contributing to this mission with 2 of our micro rovers. Each will be 5 kilogram, and we will have 2 micro rovers on board Chang'e 8 mission. So today, I would like to talk about a little bit about the story of this project, but also a little bit about the challenges that are awaiting us, what kind of problems still there exist to be solved, and what kind of proposals, what kind of technical solutions we may have to overcome these problems in the end. So the big question is, what would you send to Moon if you had chance? And our answer to this question is actually rovers. So we are going to Moon with 2 of our micro rovers again, as I mentioned. And we guaranteed to be on board the Chang'e 8 mission, which is going to the Moon in 2029. And as METU, or as Turkey, we kind of won a ticket which is approximately worth 50 million US dollars to the to get our rovers to the lunar surface. Official announcement for the project was done actually just last month on 24th of April. Before moving on with a lot of technical details, a lot of challenge, a lot of story behind the project, I would like to start with a very simple question. What is a rover? I mean, like, we are saying that we are sending 2 rovers, we have a rover project, but what is a rover at first hand? Rover is a semi-autonomous or just autonomous vehicle which is capable of moving specifically on planetary surfaces. And one nice example for rover is actually this one that you can see here. This is Perseverance rover by NASA, which was sent to Mars a few years ago, still operational and still working there. And this is actually kind of an interesting picture, but because this is actually Mars surface that you can see here. So Perseverance rover took this picture by kind of a selfie stick that it has and shared with us. If you are interested in rovers, if you would like to have a little bit more insight about all the details about challenge awaiting us, difficulties that we need to kind of overcome, there is a nice documentary that I can really suggest, which is called Goodnight OP. It is about Opportunity and Curiosity rovers, 2 other rovers which was again sent to Mars by NASA. This is, once again, this documentary is giving a lot of insight about what are the things, what are the challenges that are awaiting us. Okay, then second big question maybe, why CHERI? Like, CHERI is the acronym actually for Challenging Environment Exploration Robot for Intelligence. Challenging environment, I will talk about this challenging environment a lot, because on lunar South Pole, there are a lot of challenges awaiting us. So challenging environment part becomes clear. Exploration, yes, rovers are going there for exploring the lunar surface. And intelligence, in the end, our rovers will gather some data, some information to share us in terms of intelligence. Actually, I say us, but not just us. Of course, our rovers will be kind of a part of a very large family, including the mainlanders and including the partner rovers. So these information will be shared with all the other colleagues, all the other partners in our project. And the thing is, of course, like when we were first proposing this name for our project, it is, CHERI has some other meaning. It is a homonym, not for, Turkish kiraz, but it's a homonym for soldier, as in Yeniçeri actually. because we were just thinking that both two of our rovers will be kind of, robust, capable, versatile soldiers working on the lunar surface and doing a lot of tasks on their own and share with us. So once again, the project names comes from Yeni CHERI, or as Janissary in English, the Turkish or Ottoman soldiers that we all know. Okay, why Moon? Why now? Moon, because it is a very strategical celestial body. Many of us do not consider Moon as such strategically celestial body. I know that. For many of us, maybe it's kind of a romantic, body there, traveling in sky. For many of us, it's just, some object lightening our, kind of illuminating our dark nights. But in the end, Moon is really a, scientifically and strategically important body. Why is it that much important? Launching a spacecraft from, Earth is not financially or technically that much feasible because of atmospheric drag, because of all the disturbances, and also of course the gravity of the Earth. But we have Moon there waiting for us as kind of a stopover point. So if we can build a sustainable infrastructure on Moon, on the lunar surface, kind of a space station on lunar surface, then it can be used very easily as a gateway for our deep space exploration in that. We can have our, sustainable, once again, our sustainable space station on Moon. We can make all of our interplanetary launch departing from Moon, and we can explore further into the deep space if we have such a station. So this is why Moon is that much important. And on top of that, South Pole is even more important. Why is that? I would like to just first of all, share a very brief video with you. Let's watch together.
NASA's Lunar Reconnaissance Orbiter found new evidence of possible water ice in craters near the south pole of the Moon. Some craters have regions that look bright, with increased reflectance when illuminated with laser pulses sent from the spacecraft. Temperature readings reveal areas where it's cold enough for water ice to be stable. Areas that are both very cold and bright could be the places where water ice exists on the surface as frost.
So this short video is explaining one very, strategically and scientifically important fact. Possibly there is water in the lunar South Pole, in shape of a frozen, water, in shape of an ice. In South Pole of the Moon, when you are standing on the South Pole of the Moon, the sunlight will be coming from a very low elevation, like this, kind of elevation within few degrees. And you have almost a constant sunlight coming through you when you are standing on, once again, the South Pole. On top of that, just try to imagine, there are lots of hollow spaces, there are lots of pits, lots of craters. And of course, when the sunlight is coming from this kind of elevation, it is not possible that it penetrates through these hollow spaces. So these hollow spaces, these pits, these craters, are there without any sunlight for billions of years, and we all suspect that there are, ice in this so-called permanently shadowed regions on the lunar, South Pole. So what does water mean? Water means, of course, life, fuel, and sustainable infrastructure on the lunar South Pole. This is why, once again, on top of, Moon, South Pole is that much important. One evidence for that might be, plenty of different missions which are destined to the South Pole. Here is a very brief list. So if you just check the details of all these missions, you will see that, There is US, there is, private companies, there is Japan, there is even Singapore, which are trying to reach to the lunar South Pole. If you check, like South Pole is actually this location with all the craters, all the geographical surfaces. Luckily, as you all know, we, almost all the time, we always see the same surface of the moon because of the tidal lock. So if you would like to identify the location that we are going, where we are really going, you can see some of the geographical like kind of features to identify once again the South Pole. This is, for example, is Tycho crater. This is, for example, is Copernicus crater, and this is it's not very visible here, but this here is we have Kepler crater. So when you have a closer look to the moon, you don't need to have a telescope. You don't really need to have a very high-tech apparatus to do that. Even with your cell phone, if you look at moon, you will easily identify these geographical features, and you can understand where we are really destined to. Then, what is Chang'e 8 mission? Chang'e 8 mission is a part of the larger roadmap of China to build an international lunar research station on lunar surface. It has, already, as a part of this mission, China already sent so many different spacecraft as orbiter or lander or as rover. Last of them, the Chang'e 6 mission was sent back in 2024, and at around June, they gathered some lunar sample on the lunar surface and just brought it back to the Earth to be able to analyze the lunar regolith or lunar samples. The main idea for whole Chang'e missions is to have an in situ resource utilization, making use of oxygen, making use of soils, making use of lunar regolith to build a sustainable infrastructure on lunar surface. And of course, like it is aiming to provide a preliminary insight before they just go there for a permanent settlement, which is once again the International Lunar Research Station. And of course, what is more important, they invited, as a part of Chang'e 8 mission, they invited, international payloads, and we answered this call, and we are now on board Chang'e 8 mission. So, apart from our rovers, there will be also a rover by Hong Kong, which is a kind of a collaboration in between Hong Kong Technical University and a lot of different universities all around China. And there will be a rover by Pakistan, which is again a collaboration in between Pakistan Space Agency and the Chinese universities. The Chang'e 8 mission will be the last mission of Chang'e 8 series of missions, series of missions before the International Lunar Research Station. It will be once again destined to the South Pole. This is more or less the landing site of the Chang'e 8. I will give a little bit more insight about the landing site, but it is approximately 29th east longitude and 85th south latitude. The landing site will be. It is a plateau called Mount Smeaton. It is named after a US mathematician worked in the early age of the space exploration. So the terrain elevation is expected to be 5,300 meters. This is a closer look to the region. Here, this is exact pole location, and our landing site will be around this region. This red circle has an approximate diameter of 60 kilometers. So this is quite a large region. This is what I wanted to just share. Once again, like you can see, even with a bird eye view from the orbiter spacecraft, you can easily understand this is a rough terrain with many craters, many mountains, many highly elevated regions. So let's have a little bit more closer look. This is a 3D reconstruction of the area, which was done by one of the scientific instruments on board the Lunar Reconnaissance Orbiter, or LRO in short. LRO is one of the spacecraft by NASA, which was operational for more than 10 years, actually. So it gave us a lot of insight about the lunar structure, lunar surface. Mount Mountain is this region, once again, and approximately the area that I am circling, once again, has a diameter of 60 kilometers. So it is a large region in the end. And this picture, or this 3D reconstruction, also gives us some idea about what is awaiting us. Like here you can see there are many craters, there are many hollow regions, and you can easily understand now what I mean by permanently shadowed regions. So some of these craters are there without any direct sunlight for billions of years, once again. This is another view. Once again, this time elevation map of the region. So Mount Mountain is kind of the highest mountain on the lunar surface, and our the Chang'e 8 spacecraft, together with our rovers, will be landing on this, let's say, plateau in the end. Okay, so I already defined what is a rover, but what is a micro rover, what we are really doing. As you know, our rovers will be of approximately 5 kilograms each. There are some examples, obviously. Our rovers will not be the first rovers, first of its kind. There are some examples, but many of these examples could not do that. I mean, could not achieve a lunar landing, could not achieve going there, honestly. So one of them is by TU Delft University, Lunar Zebra. One another is IRIS by Carnegie Mellon. This one is still waiting for some ticket, let's say free ticket or some ticket to go to moon. This one was on board the Peregrine lunar lander, but the lander itself failed. So due to this failure, it couldn't make it, obviously. This Tenacious by iSpace is still in space right now. The lander, Hakuto R mission, is expected to land on lunar surface on 6th of June, next month. And there are some which had success in the end. One of these examples is by Beijing Institute of Control Engineering. We also work in very close coordination with them for our mission, actually. This one is called Jinchan. It was on board the Chang'e 6 mission. And actually, this picture here that you can see for the lander was taken by the rover itself. To the right-hand side, this is even kind of a more interesting example. This is this small rover, actually toy-like rover, is called LEV-2. It was on board JAXA's, Japan Aerospace Exploration Agency, SLIM mission last year. It is actually designed, manufactured by mainly a toy company with Takaya Tomy, in collaboration with Japan Aerospace Exploration Agency and plenty of different universities all around Japan. And it could take this picture of the lander. Lander itself, it was partially successful. When during the final landing stage of the lander, because of a failure, it kind of tipped over. So it could not, landing orientation for the rover was not perfect, but still it could, operate for more than few lunar cycles, more than few lunar days, and share us some information. And this is once again the picture of the lunar lander, which was taken by this small guy here and shared with us. And because of this thing, actually, the mission was kind of applauded in Japan a lot. Not just, once again, not just because of the lander, because of also this small rover here. Our micro rovers, we will have 2 micro rovers. Each will be approximately 5 kilograms. And the dimension will be about a shoebox size. So like kind of, 200 200 to 300 millimeters in the end in the stowed condition. Stowed means that when the solar panel is not open, they will be the first planetary rovers. We have this chance, I mean, like, we will have 2 rovers in the end. So using these 2 rovers, we have a lot of different chances to do in terms of scientific or technological demonstration, or in terms of scientific or technological mission. First of all, they will be tasking collaboratively. They will be tasking together. And one of our partners, Starvision, it's a Chinese company, will be just providing us an AI onboard processor. So our rovers will be capable of onboard processing in the end in space. They will be, because of having 2 rovers working in coordination with each other, we will have chance to get the image of same location from different perspectives. So using these plenty different images, we will have chance to build a 3D map. And technologically, we will demonstrate if such a rover, such a tiny rover is capable of surviving on lunar harsh conditions. Not just, when I talk about harsh conditions, it's not just the surface, it's not just the rough terrain, it's also including highly varying temperatures. It is also, kind of illumination conditions. And we will be testing new mobility techniques. New mobility techniques, because it will be first time that such, Rex-type wheels or Rex-type legs will be tested on lunar surface. There were some examples, there were some mission proposals, but none of them, once again, has done yet. None of them has been on Moon yet. For our configuration, we have a solar panel to the top. You can see the solar panel will be opened and will be used in this condition, like it will be opened like a book cover, and it will be kept always like this. The reason is, once again, the sunlight that our rovers will be receiving. The sunlight will be coming not directly from above us, but with a very low elevation. So the panels will be capable of, receiving this sunlight quite directly. Here, there are a few videos showing how this type of rovers might be capable of, or showing why we really preferred, Rex-type legs, because Rex-type legs specifically are very capable of moving, uneven, rough, and soft terrains. We don't really know what is waiting for us on the lunar South Pole in terms of the soil characteristics. So these kind of legs are quite capable of moving on different surfaces. They are quite adaptable. And we believe that using these type of legs, our rovers will be capable of reaching to, inaccessible points to wield or some other type of, rovers. What will be the mission? I already talked about, some of the details, but the thing is, like, in the end, of course, it will be first time for our country. It will be first time for our university. So this is already a big mission, I believe. If we can just, when we were discussing about the chief design engineer of the whole mission, like, he said that, it is not a very good, not a very easy task. And he said us that even if you just move for a few hundred meters, even if you just can take a picture of our lander, or even if you can take a picture of whole family of the Chang'e 8 mission, this is a very big success for the first time, he said us. But on top of that, what we are aiming? We are aiming, once again, demonstrating the capability of using Rex-type legs on lunar surface. We would like to have collaborative tasking with 2 rovers. We will have AI implementation for 3D mapping, and we would like to, in the end, if, everything goes well, in the end, if we have this chance, we would like to have our rovers survive the lunar night, which is lasting at about, 14 Earth days, actually. And very soon I will talk about like what kind of harsh conditions, what kind of difficult conditions are awaiting us, especially during the lunar night. So this will be whole of our mission in the end. But on top of that, of course, we are very much open to any kind of scientific contribution as well. We already have an idea, proposal to test lunar soil characteristics, because we will be there with a different type of leg, and we will be there with 2 rovers, so we will have chance to analyze lunar soil characteristics. But and once again, we will have also chance to measure the temperature with small enough sensors. But on top of that, we are once again open to any kind of further, idea in terms of scientific contribution. So it will be kind of an engineering the impossible, actually. There are many challenges awaiting us. Let me just first start with this video to the right-hand side. The spacecraft will be launched, and it will take almost 3 days for the spacecraft, Chang'e 8 spacecraft, to reach to the lunar orbit. And once it reaches the lunar orbit, still it will take multiple days, maybe multiple weeks, until the spacecraft decides about the exact landing location, performs so many observations and calculations, and then decides about the landing. Then in the end, together with the spacecraft, our rovers will be landing on lunar surface. Throughout this duration, they should be capable of resisting launch loads and vibrations, which will be quite a lot. So when we are talking about in terms of G, it will be several Gs that our spacecraft, that our rovers will be subject to. They will they have to survive in extreme temperatures. They have to move on rough terrain, harsh terrain. They have to navigate in poor illumination conditions. And they have to, once again, do all of these things at the very same time. So it will be an extreme, engineering example with quite a lot optimization, quite a lot interdisciplinary work altogether. Even this example is, explaining what I really mean. This is a leg design. So this slide is showing some of the iterations that we had. When you are designing a leg, when you are designing a wheel, it's not that straightforward. When you would like to do something on a rover which will be moving on Earth, it might be straightforward. It is a leg, right? Or it is just a wheel that you are going to put on your vehicle. But when you are doing the very same for a vehicle which will be moving on lunar surface, it has to be terrain adaptable. So it has to be you need to care about traction and mobility. It has to move quite fast, but to do that, when doing that, it has to be also durable and reliable. So it has to survive in the end. You will be using your rover for plenty of days, maybe plenty of months. So within this duration, all the wheels, all the legs must be surviving, and your design must be mass and energy efficient. So I'm just saying that these 2 rovers will be 5 kilograms. So we cannot just put 4 wheels, each 1 kilogram to our rover. They must be light enough. But on the other hand, they should be energy efficient. What does it mean? When the wheels are rotating, when the rover is moving, the motors should not consume too much power, because we have always limited power in space. And of course, in the end, they should be simple enough. They should, in terms of manufacturing, in terms of production. This one is kind of a simulation for the illumination condition in the lunar South Pole. You can see that what is really happening. So once again, sun is passing through with a very low elevation, and Earth itself is also passing through a very low elevation. And there are some permanently shadowed regions. There are some regions without any sunlight in the end. How, why is it challenging? It is challenging because just try to imagine you are trying to find your way in such a dark place. So this will be the same for our rovers. Our rovers should be moving, from point A to B in such a, dark environment from time to time. And we need to find a solution to solve this problem. And even on top of that, we have extreme temperature variations. To the right-hand side, you can see this one is for summertime, this one is for wintertime, and the top one is for nighttime, the lower one is for daytime, showing the temperature range on the lunar South Pole. So especially in the daytime, the temperature is not that much severe. It is kind of mild. But still it is from -50 to plus 50 Celsius degrees. But in the nighttime, it reaches to, a temperature at about -200 Celsius degrees. So lunar night, its lunar day cycle is something like 14 Earth days of lunar day and 14 Earth days of lunar night. So one day, lunar night or one lunar day is approximately 14 Earth days. So for 14 Earth days, our rovers should be capable of resisting such low temperatures. This is another engineering challenge that is once again awaiting us. And what are our solutions for now? We are working on these solutions. We will be just improving these solutions, but there are some ideas, obviously. We have been already working on our design for now maybe approximately 1 year. So we will be just building, we will be carefully building our rover structure. Our rover structure will be not capable of resisting against, loads and vibrations. It will be not structurally robust only against kind of, forces, but it will be robust also against ultraviolet light. It will be robust against, electromagnetic interferences, and it will be providing us kind of a thermal resistance in the end. And we are, of course, until we go to moon, we don't really have chance to experience what will be, what will our rover be subject to in the end. But what we can do, we can build a simulation environment with high fidelity. We can have a simulation environment which is close enough to what will happen in real. So with this simulation environment, that we are building, we are going to test our rovers on computer first, and then currently we are also in mid of developing an actual lunar studio, let's say, to test our rovers in future. So this is a nice video showing one of the rovers moving on the lunar surface, and the next one is this video is showing how our rover is capable of identifying different features on the lunar surface, and these features are in the end used for localization and mapping. So to the left-hand side, there is an algorithm working, which is an algorithm itself is called simultaneous localization, visual simultaneous localization and mapping algorithm. So by matching the features, by detecting the features and matching the features, the rover is currently capable of localizing itself on the lunar surface. And of course, it is not enough. So we need to also the rover has to also able to detect the obstacles awaiting in front of it. So unless it can do that, it will not be possible to avoid any kind of obstacles. So to do that, it will be capable of a depth estimation. This video is showing once again a depth estimation algorithm running simultaneously to detect kind of larger rocks, larger obstacles in front of the rover, such that rover can very easily avoid these obstacles and dynamically determine its trajectory. Okay, I think that's all for the technical part, enough for the technical part. So before concluding my presentation, my talk, obviously we are just at the beginning of our project, so there are a lot of things to do. There are lots of problems to be solved. But I also would like to give a brief insight about how we could get this project, how we came to this actual point right now. So how we started from our campus and how we are trying to go moon actually. So like at the very beginning, we were just like, many people maybe were considering us like kind of lunatics. Lunatics literally mean like moonstruck actually. So in old times, they were just referring to some mentally or crazy people as lunatics. And it is kind of matching with our situation, I guess. Because back in March 2024, I remember that I sent several emails to few professors, including the professors who are standing here right now. Kind of a this is a kind of a short version for my email, but I asked them that we have a proposal. Our proposal is successful for the initial screening, so would you like to join? And thankfully, many of these professors answered positively. They didn't think that, okay, here Ersin Hoca is one of the lunatics, forget about him. So they answered positively now, and then now we are here all together. So our team, we have, of course, in many faculty members, we have, like at the maybe heart of the project, we have Robotics and Artificial Intelligence Center. It is quite obvious. It is Robotics Center, so they have to be, at the very center of the project. And we have, of course, plenty of, once again, different departments. We have Aerospace Engineering Department, where I am also from. We have Electrical Electronics Engineering Department. We have Computing Engineering, Mechanical Engineering Department for now. And we are open to any other contributions, as I mentioned several times. And we have some partners. Thankfully, we have these partners, I say, because, you can easily understand that, culturally getting on the very same page with a, a different country is not something very easy to do. And we are talking about China here. I mean, obviously, we had a lot of challenge throughout this process. So thanks to our partners, we can just communicate more easily. We can understand each other quickly. And these two partners, one of these is, a Star Vision, which is a private company working in the AI implementation for specifically Earth orbiting, low Earth orbiting spacecraft. And another one is Zhejiang University, which is a public university. They are highly ranked, not just in China, but among all of the universities in the world. And both of these partners, Star Vision and Zhejiang University, they are both located in Hangzhou, a city which is located to the south of Shanghai. Before I went there for the first time, I was saying that, okay, Hangzhou, it's a small city probably. But then later on, we learned that it has a population about maybe more than 10 million. So it is, actually, and in the scale, it's probably larger than Ankara. So it is, once again, it's very close to Shanghai. So you can see a few images from this one is from city center, and the right one is actually the Zhejiang University. So I will not go into the details, but it all started with a visit to our department back in August 2023. So in the middle of summer, I had a phone call from my colleague telling that Deep Space Exploration Laboratory from China is visiting Ankara, and they would like to visit also our department since we are Aerospace Engineering Department. And I said, why not? Yes, they are most welcome. So they had a visit, and at that meeting, they informed us this opportunity. And later on, at the end of 2023, we sent a letter of intent to Chinese National Space Administration, or Chinese Space Agency, let's say, stating that we would like to contribute to Chang'e 8 mission. And after that, last year, back in April, the chief design engineer for the whole mission visited our university, and we had a presentation for him. And then we received the official letter of confirmation back in the end of last year, actually. And here are some photos for our last China trip. We had a, I say it was almost 10 days, but still maybe my colleagues will agree. When I just go back and look, I feel like we have been there for almost 1 month, maybe more than 1 month, because it was quite a busy schedule. But on the other hand, it was a very fruitful schedule. So here, our visit to Star Vision. This is our photo when we were having some meeting. And this is our discussion with the chief design engineer. Here in the middle, this is Professor Pei, who is the chief design engineer for the whole mission, actually, for the whole Chang'e 8 mission, when we were having a discussion with him. And maybe this is also the right point, because you will recognize our president in the photos. So I would like to thank him. We would like to thank him for being there together with us for the whole, duration, and supporting our project from the very beginning, and not considering us also kind of lunatics from the very beginning, and believing us in this project. So that was a picture from the big announcement. It was on 24th of April in China Space Day. China has a Space Day every year on exact same date in different locations. It's a very big, like kind of an event with invitees from all around the world. So it was a, kind of a big honor for us to see, of course, Turkish flag over there, and of course, our name of our university announcing that our contribution, our proposal is officially selected as one of the payloads for the mission. So before concluding, I would like to give a little bit more detail about why this project is important, or what is, what we need to do. Of course, it will be the first time for Turkey. It will be the first time for our university. So it will be a symbol for what our universities is capable of technologically and scientifically. It is a symbol showing us, if we gather together, if we work together, what we can achieve. And in the end, we will be, not building just an hardware. It will be not just a micro rover, but it will be a legacy in space research, I believe. And our students, young generation, not just maybe METU students, not just our university students, but our students, young generation of Turkey, will be, will have chance to lead the exploration with such missions. Not just, of course, our mission, but with this kind of missions. Because obviously, their era, their time will be the time of, like lunar stations, Mars habitants, asteroid mining, a lot of different progress in terms of space research. So with these kind of missions, they will be not just watching the progress, but they will be in the very heart of the progress. They will be leading the progress. They will be leading the exploration, actually, to the very front of the missions. This is also showing us, what a scientific mission, technological mission, is capable of achieving socially as well. This is, I specifically put this video because it has also kind of an interesting story. That because of a misunderstanding, we were just thinking that one of our rovers will be dropped from the lander later than the other one. So 1 day or few days later than the other one. Later on, with our communication with the responsible institution, we understood that it is actually a translation mistake. So in the English documentation that they sent to us, that they shared with us, they wrote like this, but it was kind of a translation mistake. Then they asked, what is our opinion? We told them that we would like to, have this as a chance, we would like to use this as an opportunity. They asked why. We told them that we will be just taking video of the second rover when it is being dropped, and it can be easily kind of enlarged as a kind of a social, like, let's say, not experiment, but social event, social activity, involving even the high school or mid, school students, because we all know that the gravity on Moon is 1/6 of the gravity on Earth, right? But when I just simply ask what time it will take until our rover reach to the ground, if it is dropped from 1.5 meters above the surface, yes, with a basic calculation, we can all do that. But why not showing that experimentally as well? Now, why not making it a kind of a very big event all around, our country? So what happened? We told them this idea, and then they told us that this is a very nice idea. I mean, it's a misunderstanding, but now no more it's a misunderstanding. So we are changing the schedule. So yes, you are good to go with this idea. We will be releasing your second rover later on. Okay, so this is end of my presentation. Thank you for listening. This is a nice picture that we took, we had a very short, thanks to, the regular holiday. Chinese people were not also working on Sunday. So we had few hours to visit when we were in Beijing. We had few hours to visit the Great Wall. And this small guy here is actually son of our colleague from Star Vision, who is working closer with us, Mr. Hu. So we call him Hu Jr. And we took this picture all together as a memory. It was a nice memory. So how can you get involved in this project? We have a QR code here specifically for our students. So via this QR code, you can access to a Google form. By filling this Google form, you can just inform us about your interest, how you can contribute to this project. And we already have, a website for our project and, email addresses for our project. So you can just contact us without any hesitation. We can see how we can work together. Thank you very much once again for listening.
Thank you, Hocam, for this nice talk and this good news we heard from Rector Ahmet Hoca account on LinkedIn. So it has a long story in the recent past. But you said you are open for many contributions.
Yes.
What is the current contributions you're looking for? Do you have like a 3, 4, 5 bullet point to-do list among what scientifically will be done on the surface?
Yes, first of all, we are open to any scientific contribution, as I mentioned. Like, what I mean, like...
Anything not done on Moon before?
It doesn't have to be anything not done on Moon. I mean, it can be even a simple experiment just measuring the temperature, because what I have showed with the slides over there, these are temperature expectations, temperature measurements, which were done with the lunar orbiter. So these are not exact temperature variation, measurements done on the surface. So it is still, like if we measure the temperature on lunar surface, we may just experience something quite different, or at least we can see how the local variations are for such, lunar temperature. And of course, we can just measure the magnetic field. We know that there is no permanent magnetic field for Moon, but there are local magnetic fields. So if we have just a small, magnetic instrument like a magnetometer, we can just measure the magnetic field. Or we can measure the, radiation dose that our rovers are subject to within, maybe 14 days. So any kind of scientific contribution like this, we are open. Of course, on top of that, we are also open to, you know, technological contributions. Like we have already a well-established, you know, technological roadmap. We know that what we are going to do. We know that what we need to do in the end. But why? I mean, this will be the first rover for Turkey, for our university. But obviously, honestly, it will not be the last one. So we can just start working from now on. These things will be micro rovers, but for a larger version of these rovers, we can have so many different tasks, so many different technological challenges.
I think I was approached by one of your students recently. So you have rovers on campus looking for ideas. Maybe I will be in touch with your team.
Yes, of course.
Okay. Thank you,
welcome anytime. You're welcome.
You said that the resistance on moon, that's not the exact word, is what's on yer çekimi, I mean, is 1/6 of what it is on Earth.
Yes.
Could you please compare the physical characteristics of Earth, our Earth, and those of moon, as much as it is possible, as much as we know now?
So we of course know that, I mean, there are some, I think what you mean by physical characteristics, like what our rovers will be subject to. So this is what is interesting for us. Like, obviously, when the rovers are being, first of all, when the rovers are being released from 1.5 meters, they will be just, because of the lower gravity, they will be just reaching to the surface in a kind of longer time, and they will be impacting to the surface, you know, with a rather lower velocity compared to what we will be experiencing on Earth. And the traction, you know, physical characteristics for the wheels, physical characteristics for the movement will be a little bit different than what we will be experiencing. And on top of that, there is another challenge that is awaiting us. Because of low gravity, you can just imagine yourself that you are moving on a kind of a desert or on a kind of a, you know, like beach full of sand. But because of low gravity, whenever our rovers kick, the sand will be kind of flying. So it will be, you know, sticking to our, you know, like surfaces. It will be sticking to our, the devices, our instrument on the lunar surface. So these are kind of differences for the physical characteristics. But of course, geographically, I'm not, you know, like honestly a physicist. I'm not like specifically astrophysicist. So there may be a lot of, if we just compare two celestial bodies in terms of, you know, characteristics, there are of course many differences. But, you know, many of them are also maybe kind of unknown for us until we really go there, until we really experience them in real life. You're welcome.
So my understanding is that this is a one-way mission, right? There will be no physical collection of any materials, just data.
That's right. That's right.
Or they will be totally autonomous and we will just give high-level commands. And especially like I want to ask when we can communicate, like is there any night-day difference or some sort of interruption in the communication, this kind of problems?
I think, so what you are asking, I think both of them are possible. I mean, like autonomous tasking and also tasking via some ground commands will be possible. There will be a master command in the end, because obviously we don't really know that what will be the landing place eventually. Yes, it will try to land to the most optimal location, but usually this is not happening all the time. There was one quite recent example by intuitive machines. They tried to land on lunar surface, but they could not success mostly because of the visual navigation algorithms. So once the spacecraft is on lunar surface, there will be some commands, master commands shared with the spacecraft. But then for our rovers, the main commands will be via the communication through the lander. So we will be communicating via the lander, and our rovers will be together with the other rovers, and together with the lander, they will be sharing a mass communication solution, mass grid kind of communication solution. And we know that our rovers will be capable of communicating with the lander within a radius of 150 meters. If they are working closely together with the other rovers, other larger rovers, this distance even gets longer. So our rovers can go even further spaces. But in the end, so it will be a mixture of both autonomous tasking and tasking via ground commands.
Thank you very much.
Yeah, welcome.
Similar question.
Yes.
What sort of data is it going to send to the Earth? What sort of data?
What
kind of data?
So whatever we want. First of all, Chinese side is very much open to this kind of information. So whatever we desire, whatever information we would like to collect from our rovers, we will get it. So it can be just, for example, power characteristics, measuring the traction capability, mobility capability of our rovers.
About lunar surface?
Yes. What?
About the moon surface, what sort of data?
From the moon surface. From the moon surface, the data, we will get visual data. This is most important for us.
Pictures, do you mean?
Yes, picture and 3D mapping. And we will try to, our partner, StarVision, will try to implement their AI processors on board. So it means it will be kind of an edge computing algorithm. So they will try to build the 3D map on board the rovers, or in worst case, on board the lander itself. So it will be sharing us a 3D map of the surrounding environment. And on top of that, with the scientific contributions, with the scientific measurements, we will gather, again, the temperature, magnetic field type of, data of the lunar surface.
Now, where is the receiver on the Earth?
In the receiver on the Earth, of course, it's in China.
China.
Yes. Yeah, welcome.
First, I would like to thank for all the effort and the work put on this project, and that's very, very nice way of also representing our country and our university. My question is about more the technical side of the CHERI. I mean, what is the, as I do have no idea about its mechanical functioning, what is the time of such an instrument? How long it is planned to remain on the moon surface within fulfillment of its duties?
So this is a nice question, because in the end, it is also very tightly connected to one of the challenges that is awaiting us. For now, there is no such micro rover which could survive more than 14 days. I say 14 days because 14 days is the exact day for the lunar day and night circle, as I mentioned. After 14 days, night comes. And with the night, our rover will be subject to extreme low temperatures. So we will be trying to survive such extreme. There are examples for larger rovers, obviously, but larger rovers are more complex with heaters, with active thermal control, etc. So with 5 kilogram of tiny rovers, you cannot achieve all of them. But now, technologically or scientifically, we are also investigating, and together with our partners, we are investigating how to solve this problem and whether our rovers will be capable of surviving more than 14 days. But we are doing all of our plans for obviously 14 days. If we can survive more than 14 days, it will be a big technological and scientific achievement, and we will just extend the scope of the mission.
Thank you.
Yeah, welcome.
As far as I know, on the moon surface, the rocks are very characteristic due to the lack of atmosphere, and they are very sharp, like knife edge.
Yes.
And in large size rovers, maybe it's not a problem, but in this kind of small size vehicles, especially in the wheel design, what kind of material do you want to use in order to, prevent this mechanical corrosion?
Very nice question. I think my colleagues from specifically interested in the structure and material selection can give a lot of more details. But now we are searching many different materials actually. Maybe some composite structure which is reinforced with some metal can be one solution. But we need to verify this kind of things with the experiments. This is why I specifically emphasized about the wheel design at the mid of my presentation, because it has to be light. Yes, one aspect is what you have mentioned, it has to be robust. It has to be structurally strong enough to sustain throughout the whole mission. But on the other hand, we cannot make a very heavy design for our wheels because of our limited capacity. So once again, we are now considering many different materials, but maybe much more detail can be shared by my colleagues who are more into this field.
Thank you.
Yeah, welcome.
Thanks for the presentation, Hoca. I think one of the Chang'e mission, the rover landed on the far side of the moon. So moon canceled the signal with the Earth, and they needed another satellite to make communication. Do you have such a problem for the poles?
No, we don't have such a problem for the poles. And on top of that, of course, it will be, once again, Chang'e 8 mission will be China's mission. So in the end, even if we have, communication problem, they still can use their own satellites. Their own satellites is still operational on lunar orbit, and they are using it for observations. So as you mentioned, for Chang'e 6, also they used this satellite for communicating. So from the lander to the satellite and to the satellite to the Earth.
And I have another question.
Yeah.
Are these two rovers identical? I hope won't, but if one of the rover will fail, can the other one perform the mission?
If one of them fails, of course, it will be kind of a partial failure for the mission. So, for example, it will be not possible to have 3D mapping just using one rover. Maybe we can just still get the picture of the very same scene from different perspectives using the same rover, but it will be, a little bit more difficult. Your question, we are now considering to have identical rovers. It has advantages and disadvantages, but, right at the moment, we would like to make both of them, identical.
Thank you.
You're welcome.
Hemen bölüyorum hocam. Konu çok kıymetli. Sizin de sunumunuz çok değerliydi.
Tabii.
Ama kokteyl kısmımızda kalan sorularımızı alabiliriz. Sizin için de bir mahsur yoksa tabii ki. Tamamdır o zaman. Teşekkür ediyoruz tekrar. Kıymetli hocamız doçent doktor Sayın Halil Ersin Söken'e sunumu için tekrar sizlerin huzurunda teşekkür ederiz. Katılımlarınızla değerlendik. Bir sonraki Learn and Connect'te görüşmek üzere. Kokteyle geçebiliriz. İyi akşamlar.